All right, we're going to go through a quick demonstration of the Teleop using the encoders for distance calculation. So this script, available in the link in the description, is just going to set up all our encoders and motors on the Raspberry Pi, and then request the user for input for forward, reverse, left, or right, and distance or angle for each of those commands. And then it will execute them using the encoders to track if it's successfully reached the desired pose. So one thing to note, because we are using skid steer and these motors are not the most powerful, I've increased the PWM duty for the turn to 75. So basically that means we're going to give it we're going to ask for faster motor speed in the turn, which is just the PWM will be high for longer, which effectively will also give us more torque. And I was noticing that if the duty was too low, we would just get stuck. We wouldn't be able to turn at all. And that's due to our skid steer. When one side is turning forward and the other side is turning reverse, the wheels are going to slip and stick, and our motors just aren't powerful enough to overcome it sometimes. The other thing to note is, because of that, I also changed the PWM duty for straight to be lower so that we can have more accurate encoder counts. The Raspberry Pi isn't perfect. Sometimes it misses encoder tick if you're going too quickly. So I chose 50% as a good, happy medium. So without further ado, let's go ahead and run this. So we'll run the Teleop there, and it gives you some options. We've got a robot here, just for an orientation reference. Let's go ahead and we'll choose left, and we'll go 90 degrees to the left. And we can see it turns 90 degrees to the left. So now I'm not going to show you the screen, but I will show you, we'll go right 90 degrees and you'll see that. So as you can see, we're tracking the left and right encoder ticks separately, and the left got the number of ticks required first, so the left side stopped, and the right side kept going because it hadn't quite hit that. It's kind of an issue with our skid steer system is because we're experiencing slip and jumps and stickage, the encoder counts aren't perfect. This would be better in like if we had a two-wheel drive system with a slider in the front, like the Turtlebots use. But we're using a four-wheel drive system, so we'll have to deal with the skid steer. Let's try reverse. I'm gonna turn right actually first by 90 degrees so we have some room. All right, now let's go backwards by 10 centimeters. And that was a great straight line backwards movement. So our reverse is great. Let's do forward just to have the complete set. And we'll do 20 centimeters. So forward and reverse, awesome. We don't experience the skid steer in forward and reverse. The encoders seem to be relatively accurate and moving in a straight line. Thanks for watching.